There is grandeur in this view of life.
Welcome to Evolution Talk with Rick Coast, an introduction to the oldest story ever told.
Imagine a world without mutants. Now, I don't mean those superpowered heroes that populate the comics and movies from Marvel. I'm talking about you, me, and, well, everyone else we know. And it doesn't stop there. It extends to the grass at our feet, the trees and plants that provide us with oxygen, and the bear that knocked down your bird feeder the other night. We are all mutants trying to survive. So, back to my initial suggestion. Can you imagine a world without mutants? Now, close your eyes and think about that for a moment. I'll tell you what I see. I see nothing. Nothing at all. There wouldn't be anything or anybody here. I wouldn't be able to record this, and I wouldn't be able to record this, and you wouldn't be here to tell me I'm boring and to get to the point. Okay, so the point is, we are lucky to live in an imperfect world. If you want to talk about boring, perfection is boring. The Venus de Milo is a beautiful sculpture. It's over 2,000 years old. It's sculpted in marble and is one of the most famous of its kind in the world. It's also missing both arms. That's imperfection. If you listen closely to Led Zeppelin's Since I've Been Loving You, you might notice a barely audible squeaking sound. That's John Bonham's drum pedal. Apparently oiling it was out of the question. That's also imperfection. Here's one more. I bought a new book the other day, one by a famous philosopher. It's his new book, actually, and I won't call him out on it because this isn't his fault, it's the editor's fault. But within the first 2 chapters, I found a spelling error. Another imperfection. Granted, the squeaky drum pedal and the spelling error are probably imperfections we could do without, but imperfections give birth to creativity. And nature is a mindless creator that uses the raw materials provided by mutations, or imperfections in the copying routine, to shape the world around us. When he wrote his great book, Charles Darwin knew that changes which occurred between parent and offspring provided nature with something to work with, something to be creative with. He saw this in the barnacles he studied and the pigeons that he bred. What he didn't know was the how. How did they occur and how did they persist? What was the mechanism that allowed for adaptations? Our genes. Darwin didn't know about genes at the time. Our genes are made of DNA. Now, I won't get into the nature of DNA and the specifics of the replication process here. We've touched upon that in past episodes. But I will say that genes are similar to lines in an instruction manual for building an organism. All living life has a manual like this. When a child is born, or a calf or a kitten, a copy of that manual is made so the child can be formed. While the replication process is often perfect, errors can happen, and they do. Those random genetic errors or changes to the instruction manual are passed on the next time a child is formed. A change can be beneficial, it can be harmful, or it can do nothing at all. A genetic change, when it happens, can have some pretty profound effects. It all depends on what the change does and how it affects the organism's ability to survive in its environment. It's not survival of the fittest, it's just survival, period. So why not survival of the fittest? Well, that term, and I think we've also discussed this before, that term leads to an assortment of wrong conclusions. An animal doesn't have to be fitter than its competitor, it only has to be good enough to survive, long enough to reproduce. An animal can be small, weak, and have a short lifespan, while its competitor is large, predatory, and lives twice as long. It doesn't mean that the larger animal is fitter. They both consume resources and have offspring. If they go after the same resource, well, then competition ensues, and it's anyone's guess who will win out. A number of environmental factors have to come into play. But it's safe to say it has nothing to do with being fit or being stronger. So, back to mutations. What causes them? Well, they can happen during the copying process itself, or they can happen because of exposure to, say, radiation or some other environmental factor. How about me? So my DNA could be affected during my lifetime. And if it affects the cells used in reproduction, well, that change can be passed on to my child. So I want to stop there for a moment. What was it that I just said there? Now that sounds an awful lot like something Jean-Baptiste Lamarck would have said. He said that what happens to an animal in its lifetime can be passed on to its offspring. Now, that's only part of it. What Lamarck was concerned with had everything to do with use and disuse, like a giraffe's neck. That's a favorite example often tied to Lamarck's comments about use and disuse. The more the giraffe stretches to reach the leaves, the longer its neck, which is then passed on. Its children do the same, and the result of that effort is all passed on. It all leads to long necks. Or so he said. So the same idea was applied to moles and eyesight. They stop relying on vision, so they go blind. That's not true either. Moles have poor eyesight not because they stopped using their eyes. It's because a genetic mutation in the genes that affect eye formation reduced their ability to see. But it didn't hamper their ability to live in the environment they'd adapted to. Mutations also led to longer necks for giraffes. It had nothing to do with straining or stretching. Now, we are all the result of changes that affected the genes of our ancestors. It's safe to say that those adaptations were beneficial. It's why they are called adaptations and not genetic disorders. If they weren't beneficial, we wouldn't be here today, not a single one of us. So again, try to imagine a world where the replication process was always perfect, where every copy was exact and never changing. Not only would it be yawn-inducing, but it also wouldn't help a fish survive if the environment it lived in began to gradually drop in temperature. But allow for a slight genetic mutation, say one where it provides the fish with blood-like antifreeze, and you'd have a wonderful adaptation and the means to survive in an ever-changing world. That's actually happened too. Fish in cold climates like the Arctic and the Antarctic, a good example is the Arctic cod, have evolved this way. And separately, on opposite ends of the world. Think about that.
So, I'm interested in the genetic and epigenetic underpinnings of biological function and form and diversity. And I'm also interested in understanding how all of these systems evolved. And so when we consider the function of a gene or the behavior of a cell, we want to understand both how that thing is working in a living extant organism and also how the evolutionary process that has taken place before we could really observe it might have led to that characteristic. So when we think about evolution, which is, heritable change over time, we know that we need three main things for evolution to happen. Really, we just need two, and the third is sort of a bonus. So we need variation. If everything is identical, there's no change to be made. And so evolution can't happen under completely static conditions with no variance. In terms of evolutionary change, we're interested in heritable change. That means we need these variations to be heritable. So that's a second key pillar. With just those two things alone, you can have different patterns of heritability of variation, and you can get, by definition, evolutionary change. Now, if any of these variations are also linked to variations in fitness, then you have the opportunity for one particular mechanism to operate on the evolutionary process, and that is natural selection.
That was Canadian geneticist Cassandra Extavor. So we see this all around us. The trees, the birds, the cows, and, well, the raccoon my outside camera caught on video last night. All are the results of slight genetic mutations that accumulated over time to create the abundance of species we see all around us. I hope you enjoyed today's episode of Evolution Talk. I'm Rick Coast, and you can find show notes and source material used for this episode at evolutiontalk.com. I hope your week is going well, and until next time, please take care of yourself.
Evolution Talk is a Rick Coast production.